All right, we're back. We are on page 28 of math analysis. I think we're in notes 3. And if you look, you can see we have another blank unit circle. So we're going to try to fill this in. We're trying to get faster. I seem to have hit my limit, though. I don't think I can do it in under 90 seconds on this iPad. I'm going to try, but like it's just too hard. All right, so here we go. You got to like limber yourself up. And I'm going to do angles first, then I'm going to do points, and then I'm probably going to complain about how long it took. So let's see how it goes. All right, ready, set, go. Trying. Such exciting videos. Come on. I feel like some weird kind of spin instructor. Trying to like get myself hyped up for this. Ah, that cost me. Positive. What are you doing? All right, I don't know. I never know until I get to the end of the video, and then I'll like. Sometimes I actually watch it to see if I got it. Like it seems like 100 seconds is about like the limit I can do. I want to blame the iPad, but I mean it's also partly my brain, and also partly the fact that like I never hand wrote anything until about like 2 months ago. I had almost completely given up on the notion of it. It was all like giant whiteboards and typing. Then COVID-19 started writing, had to fill out all the notes. So it's been interesting. Like skills that I thought I would never have to use again, I've had to bust out. All right, let's take a look at this. So using the unit circle figure, use the unit circle to figure out if each of these functions is increasing or decreasing in each quadrant. So I guarantee you that within each quadrant, the function is either increasing or decreasing. So that's kind of like a thing you need to know. Let's take a look at sine, for example. So sine is the y value. It starts at 0 when on the quadrantal. Then it goes up to 1/2, up, up, up. It goes up all the way through. So that must mean increasing. Should we just keep going for sine, I guess? So now we go from 1 to smaller, smaller still, smaller still, smaller still, decreasing. Okay, let's keep going. So you're going to keep getting smaller until you get to the minimum value, which is -1. So that decreased all the way through there. And then we're going to increase back up to 0. So looks like sine is increasing in the first quadrant, decreasing in 2 and 3, and then increasing again in quadrant 4. So this is going to be useful to know. That means that in the first quadrant, if an angle is bigger, its sine is bigger. Like that's useful information. Let's do cosine. So cosine, really similar, but exactly kind of the opposite. We start at the biggest it will ever be, and then we just get smaller all the way until pi, right? So you start at the biggest and you go to the smallest value, which happens at pi, which means in quadrants 1 and 2, we are decreasing. Now we're going to go from the smallest possible value, which is -1, back up to the biggest value, which is +1. So actually, you kind of get the sense, the very real, very important sense, that the range of sine and cosine based on the unit circle must be from -1 to 1, right? The y value can go down to -1, can go up to +1. That's a range of 1 for sine. The x value can go from -1 all the way up to +1. That's a range of -1 to 1 for cosine. So the range of sine and cosine, both -1 to 1. That's going to be useful information. So the next thing we want to do is the tangents, which are like no one ever has a tangents, really like a good sense of them. I'm going to go through, I'll fill them in like a weird color, and I'm going to do it like on the radial lines, I guess, because I don't really have room around the edge. So the tangent of 0 is 0, and then it's root 3 over 3 over 3, and then 1, and then just root 3. And then undefined. So what happened, though, is we went 0, root 3 over 3 is less than 1, to 1, to root 3, which is bigger than 1. Tangent has increased. So I'm going to say increasing in quadrant 1. Okay, so now, so in quadrant 2, sine, ASTC, right? Sine and cosecant are positive, everything else is negative. So we're going to get negatives. The tangent of a pi over 3 angle should be, the absolute value of that tangent should be radical 3. So this will be negative root 3, then -1, then negative root 3 over 3, and then it'll be 0 when we get to pi. So think about that. Negative root 3 is actually the smallest number there because it's the farthest left on the number line. So we go from negative root 3 to -1, which is a little bigger, to negative root 3 over 3, which is a little bigger, to 0. It actually increased all the way through. Increasing. Interesting. And now we're going to keep going. So third quadrant, tangent is positive. So we're going to get root 3 over 3, 1, root 3, and then back to undefined. But the key thing is 0 to root 3 over 3 got bigger, to 1 got bigger, to root 3 got bigger. We actually increase all the way through here. Okay. Increase all the way through there. And then will the same thing happen? So, I mean, how weird would it be if in quadrants 1, 2, and 3 it increases, and then for some reason in quadrant 4 it decreases? Seems unlikely. So here we're going to go negative root 3 because only cosine is positive. 3's are so hard, and I have to write so many of them. Here, negative, negative. So again, we're going from the most negative number up to 0. That increases. So we can actually use the unit circle to decide if we are increasing or decreasing for our functions, which the unit circle is just so useful. Knowing the unit circle, being able to like knock it out really fast. 90 seconds is definitely your goal. Try to get under that. You've watched me struggle. I seem not to be able to. That's really disappointing. I think I actually might just do one on paper later just to like see, can I actually do it? So why is all this useful? Well, I know that in the first quadrant, cosine is decreasing, right? So if I think about it, that means that as an angle gets bigger in the first quadrant, its cosine gets smaller. So I can immediately say, if I want to compare these without a calculator, I can immediately say that the cosine of 20 is going to be less than the cosine of 10. And I can say because cosine decreases in quadrant 1. Now, quadrant 1. It's also really useful to draw a picture. And when you draw your picture, it's okay to exaggerate. We're just trying to compare the two angles. So like we know that the picture I'm about to draw is not really accurate, but we're okay with that. So I'm going to draw like a tiny little unit circle, or try to. And then I'm going to draw my circle. I'm going to let the app turn that into nothing somehow. Okay, we got a circle. Try to center it correctly. I think that's right. I mean, there are little like tick marks on the app that say that that is in the right place. Let me actually copy this. Let's duplicate you. Let's put this in everywhere so we can like draw a lot of pictures. How many of these do we need? That's frustrating. It's doing that thing where it like locks on with guides, but my hand is really unsteady, so I keep losing it. Okay, so we got a picture we can use for all of them. All right, so here, what I was saying was that if you draw 10 degrees, maybe like here, and then you draw 20 degrees, exaggerate it, right? So 20 degrees, I know that this is not right, but whatever, 20 degrees is bigger than 10 degrees, so just draw something bigger in the right quadrant. You can definitely see we're comparing x values, right? So since we're comparing x values, the x value at this point is way bigger than the x value at this point, which means the cosine of 10 degrees is definitely bigger than the cosine of 20 degrees. Also, I don't know why I wrote it as cosine of 20 is smaller than cosine of 10. Like, generally speaking, you would prefer to use greater than. So I think a better answer would be to say cosine of 10 is bigger than cosine of 20. I'm aware, obviously, that these are the same thing, but like you really do have a preference in life for saying like is greater than. So cosine of 10 is greater than the cosine of 20 because cosine decreases in quadrant 1. That's probably what I would have gone with if I thought it through a little bit more. I'm actually going to stop this here, come back in the next video and finish this up. And well, actually, no, you know what? I'm going to do this one because it's like the same basic idea. So let's do our thing, right? So 15 degrees and then 25 degrees, be extreme. Don't be accurate, be extreme. Okay, so this sine, you're comparing y values. So I'm going to say that the sine of 25 degrees is definitely greater than the sine of 15 degrees. I know that visually from the unit circle, right? Because 25 degrees is higher up and y is the sine. So I know this is definitely true, but the justification I'm going to give is because sine increases in quadrant 1, and we are in quadrant 1. So I'm going to give that as my reasoning. So it's a better reason than just like kind of, fumble your way through. But anyway, I'll be back in the next video to finish this page, hopefully. So I will see you there.